Hey, my name's Lee Connell, and this is the Assignment 3 Pavement Construction Report regarding the Riverview Bypass Project. Okay, so the project overview. Uh, the purpose of the project is to enhance freight efficiency, um, bypassing the town of Riverview. It's an 8 kilometre bypass. There's predominantly for the biggest vehicle is predominantly B doubles. Design aspects are it's a single carriageway, 100 km/h design speed, two 3.5 metre lanes in each, one 3.5 metre lane in each direction, so 2 lanes all up, and a metre wide shoulders either side. Traffic design is 8 by 10 to the 6 design traffic. So the location and alignment, we've got on the north side is a floodplain area. 3 kilometres of the road goes through that floodplain area. On the south side, we've got about another 5 kilometres there, and that's through predominantly sandy, above the floodplain, but through sandy soils. We're going to talk a little bit about those sections. Through the middle of the job, we have at the 3 kilometre mark a culvert for the Black River crossing. So we've got to work out some aspects with the culvert, as well as the town of Riverview adjacent the project site. Either side of the road we have landholders growing sensitive crops, so we need to make sure that we mitigate dust in particular, but other they can't have contamination in their crops. So geotechnical conditions, like I said, the northern section is through a floodplain. It's got a high water table, predominantly silty clay, some highly plastic soils. CBRs are around about 3 mark expectation. It could well be even less, areas of less given the NT. Southern section is elevated sandy terrain, CBR about 10, typically dense sandy soils, pretty good for constructing on really. Northern section pavement design, as a benchmark design, it comes in at 640 millimetres in thickness, chosen about 160 mil of type 2.1 and 360 mil layers of type 2.3. This is based on a CBR 3%. We can significantly de-risk the project by treating that subgrade. What happens there is that working across a clay subgrade in the NT is fraught with prolongation and delays as a result of any water or a late wet season downpour, a bit like what we've got this year in parts around the northern Australia. That water on the floodplain in clay soils will delay the contractor from starting works. Delaying starting works has a risk there that you're unable to get the seal down before Christmas. If you want to seal any time after Christmas, you really aren't doing that in Northern Australia until Anzac Day. It is just absolutely fraught with risk. You'd have to be very highly pushed and motivated to get the seal down any time between Christmas and Anzac Day. And that poses quality risk. So there is some very good reasons for going for a subgrade treatment. We're going to look at a couple of them. So we've got we'll go have a look at geotextile. Geotextile still requires a cover over the top. The downside is you can push that material out and then you're going to have to put some kind of an imported fill over the top. Typically a graded material over the top, can't be too large for risk puncturing that geotextile, but a geotextile can still work in very conditions. But again, you still have to get construction traffic over, create a tip head and move off the job that way. So it is in soft conditions, you can still be fraught with that. Imported fill, for the same reason we just talked about, you've got to dig out the material, then you've got to bring in imported material. So actually got 2 lots of truck movements on that fill. So again, high cost, environmental impact of cartage. What are you going to do with all the material that you cart away as well too? Which leads us to lime stabilisation. Now, lime has been well used for being able to create a pozzolanic effect within the clay, thereby improving the stability, improving the strength, and decreasing the shrinkage of that layer that's been treated. It's a relatively moderate cost for the de-risking and the conditions, the improvement there that it does make. That cost can also be offset against the importation or the reduction in paper materials, which we'll see in the next couple of slides. Financial analysis. So we've done some of that, and it's come in at $10 a square metre reduction over the benchmark, which is the 600mm pavement versus a 400mm pavement. That's an analysis. So we've got this lime stabilisation approach. So the layer design we've gone with is a 200mm stabilised layer. Now this is a layer has been chosen to make sure that we don't, we could have gone thicker. That would have needed to have been built in 2 layers. So then you would be targeting maybe 300 to 400 mils, which then means that you've got to remove some material and bring it back when you're doing the second layer. Didn't really want to do that, just do it in 1 layer. 200 mil is about the thickest there that you can compact with a lime stabilised clay. So you really want to be targeting that thick layer to get the most out of the work that you're going to do. Now, the process of lime stabilisation revolves around trimming up the subgrade 2 levels, getting it about there, giving it some nominal compaction so you can still work on it, spreading about half the lime. We're going to use hydrated lime, so that means it does not need to be slaked. The reason for that is when you slake it creates dust and fizzles, and that produces a hazard to not only the guys on site but also the crops adjacent the alignment. So we don't want to be contaminating those crops with this lime. This was a key factor there that the landholders have said they don't want to happen. So we can mitigate that by using hydrated lime. We've chosen about a 3% for this analysis. And the way it would work is you'd put down about half of the lime spread out, as you've seen on the screen here, with the and the mixer is now going over the top. So what we're seeing here is the first pass has been done, and typically a water truck would hook up to this bar and hook up this pusher bar, and then the water cart would be connected up to this hose, and water is fed into the mixing drum, and the stabilizer and the water cart proceed along and injecting water and doing the half mixing. Now, one nominal compaction is put over the top just to seal it, and it's left to mellow for 24 hours at least. The reason for the mellowing is it breaks down the clay particles, and then the next day we go back and we spread the rest of the lime. Like I said, we do half in the first pass. The second pass we add the last part. It can be a little bit more in the first pass if you want, and we would add in the last part. Now here what we're seeing is there's no water cart here, so this is on the second pass, and the reason for that is the guys made sure that when they did the first pass they had a lot more water than what they needed to, and it means that the clay and the moisture has more time to equalise within that 200 mil of stabilised pavements. And we've checked the moistures there. The guys have checked the moistures and they've come in really good. They're really happy with that moisture. They don't need to add too much more, and they're just going to stabilise the lime that's here and stabilise it in. Now, some quality aspects there that need to be taken is we should be seeing the mixing supervisor going along the back of the mixer, ensuring that the materials are adequately mixed, that the depth has been achieved of at least 200 mil, and that the moisture content is right. So doing the squeeze test. So we're going to, as a demonstration of this, we're going to do a tale of two subgrades. So two similar floodplain projects started simultaneously. This is a typical floodplain. Water's been on the alignment. So project one had no lime stabilisation. It was focused on initial cost savings. Unseasonal rains in May caused machinery to bog, and that significantly delayed the job, caused frustration for the contractor and the project team, and ultimately the community was frustrated as well too. Now the further downside to that was they lost a month with that work, trying to get back onto the clay, being bogged, all those kind of aspects, which meant that where they were going to seal in November, December, it got delayed. A monsoon burst came through. They couldn't seal the job, and they had to then seal at the back end in April. So starting the project in the NT on a floodplain without lime stabilising is really risky at the back end of the job, trying to get it sealed before those monsoonal bursts come. Project 2, on the other hand, used lime stabilisation. The contractor knew what they were doing. They, as soon as they were clearing grub, they got on and lime stabilised it, created themselves a nice working platform. From there, the job just proceeded one after the other. They continued on. They got the rain. They got the rain that the first project had as well too. Just like on this project here, there was water sitting there everywhere. Well, the contractor, all they had to do was just trim up that subgrade, and they missed the day of rain plus the half a day that they left to let it settle, and the contractor trimmed it up, windrowed a little bit, and away they went. They with the windrow lime mixed material, they were able to bring it back once it was dry, and reincorporate that into the subgrade. All they had to do was trim up and not travel on the area that hadn't been lime stabilised, and they were right to go. So, and again, this contractor then was able to proceed with the job, which meant that they hit their schedule alignment at seal time at the end of the job. Okay, so the southern section pavement design, we've got a total thickness there of 320 millimetres, consisting of 150 mil of base and 170 mil of sub-base. Subgrade CBR here is 10. Now, remembering it's on a dense sandy soil, so there's not really too much risk there. About the only thing would be any soft areas, which we can pick up during construction. The trucks will certainly find that. DCP should be used to confirm that subgrade CBR on that sandy materials. Okay, so the intersections. We've got some the intersections there that you see are aligned about the alignment of what they're going to do. Now there is some aspects there with construction we can mitigate, and the pavement as well too. So in a perfect world, we would do a construction bypass of this area on the western side for both of these. Now we may not be able to do that because of fencing or services that need to be relocated, for instance, as well as cost as well too. Now there's an aspect here that probably needs to be addressed in terms of whether this intersection here, this deacceleration lane, needs to go in through here. So the geometric designers need to have a look at those aspects and whether an acceleration lane needs to go in here. Now, those particular aspects add up to to increase the pavement area, but this could be supplemented through reducing the detour on the western side, removing that, and building the pavement in half and half. So what I mean by that is building this side of the pavement here, and then constructing, putting traffic on this side of the road and building out this side, and then coming back and building this bit later. So doing that half and half, not having to put in this detour around here, depending on the ground conditions there for that bypass. Okay, so the spray seal, we are going to go with a 14mm P&B S10E on a prime surface. This is different to the NT standard specifications in that typically there would be a double P&B surface being called for. We still recommend that the double 14.7 P&B S10E goes down. So that is something there that we believe should be done. At the very least, if a single seal is what the client is going to go for, then that should be a P&B S10E. The intersections call for a 30mm DG asphalt. We're opting to put in a 7mm single sprayed seal. Again, an S10E, a P&B S10E. The reason for that is to improve the waterproofness of that pavement. All up, the spray seal and asphalt areas come to about 94,000 square metres, so it's a decent sized job. The works plan is having the intersections sealed first. They'll be used, constructed first and sealed. The 7mm seal will act as a surface to travel on until such time as at the end of the job, bringing in the asphalt crew to do both intersections at once. Now, important aspect on the right-hand side here is this prime over a type 2.1. So those pavement batters, we should really be priming all the way down to the underside of the type 2.3 or the sub-base layers. And that is to prevent this scouring from occurring during that rainfall. Now, this was a really tight compacted batter. It still scours. There's not enough fines in a type 2.1 to keep that there. But you can see here that with the primed edge, that holds together. So this prime edge needs to go down over the top of the sub base there. So here's our list of plant and equipment here. Not too much dissimilar from what we would typically have on a road job. Some aspects there to consider is that asphalt, getting asphalt out here may be a problem. There was a supplier in town. If not, then we can still do a spray seal solution for that surfacing in lieu of the DG asphalt. That would entail a double seal 14.7 and a sand lockdown treatment there to do that. The other aspects is the stabilisation spreader and the stabiliser, having a decent size stabiliser to ensure that the contractor can mix adequately. The full depth clay can get pretty tough on the stabilisers, pretty dense, and a big pad foot roller, an over 20 tonne kind of roller, just to compact that lime stabilisation down adequately. All right, so material quantities, we have 33,000 odd cubic metres worth of material going in. So 85,000 tonne or thereabouts, about 3,000 truck movements all up. So a key part of this is building the intersections first, putting the trucks away from going through Riverview, getting them down the alignment, building from the northern side, building that lime stabilisation. The trucks run on that. They run on the sub base over the top of the culvert, and finally building the southern side. So truck traffic on the alignment, keeping that water up to ensure that dust is not mitigating or not impacting on the. All right, so construction schedule we've got starting in February, using those early period to mobilise the site, do those preliminaries, do some clearing and grubbing. As soon as it's dry enough, is working on that lime stabilisation, starting at the culvert, whacking in that culvert down the temporary culvert, the low flow culvert here, doing the embankment construction over the top of that culvert so we can move trucks from northern side to southern side. Lime stabilisation, in addition, once that's finished on the northern intersection, going on and building the northern and southern intersections again to facilitate those pavement materials coming in through that period of time. We've also got pavement construction happening and on the north side and then proceeding on the south side. Finally, at month 8, which should be about October, November, we should be starting to see spray, seal, asphalt, and finally pavement markings and road furniture going down. So in summary, we've got the northern section implementing lime stabilisation because it does de-risk the project, reduces the pavement thickness and in turn costs. Some aspects there that we should be considering too is the conduct of a detailed study for the floodplain drainage and the road, the hydrology, so whether the road needs to be lifted up or kept down, and the impact that has on the community. The community will be very interested in that. The stakeholder engagement needs to progress to manage the community heritage and stakeholder interactions, and the detailed design needs to be developed. And lastly, we've got this the recommended pavement design over here. Thank you.